Let's go to the second presentation of today by my friend Lawrence Lin, who is a veteran in the lighting industry, but now is more focusing on not light for vision, but light for health.
Thank you. Okay, so thank you, Yan, to having me here to share some of my experience and my view on the design logic for the healthy indoor lighting from I think the most likely from some researchers, but also I think most likely from the application as a lighting manufacturers. So myself, I'm just been engaged by the IWBI, the International Well Building Institute, for the 2025 Well Lighting Concept Advisory, and I'm also the founder and CEO of the Lighting Recipe Studio. And also, I used to be working for industry for 27 more years in the LED and the lighting, from the LED packaging, luminaries, lamps, cross-border M&A, especially I used to be the global CEO of LabBanks and also used to be the chairman supervisor of the LabBanks. So I'm now founding the Lighting Recipe Studio from I think 2022. From now, we dedicated on build up some. I would say that the path and the gap to close the gap, to fill the gap for the indoor healthy lighting design. There's some equipment, also some researches to identify some evidence-based researches to support the indoor health lighting design. So I think I think we all know, have some basic idea, understand what is actually the healthy indoor lighting. But I think have the quick glance. I think the light, air, water is the three elements for life. And the people, we human beings, already been the 7 million years evolution, which is most likely in the nature light impact situation. And the artificial electric light only developed for approximately 150 years. But now that also we all know, we probably have more than 87%, approximately at 90%. Modern human beings that spend our life for indoors. And many the evidence already told us how light is important for our human health. So some disease already been recognized is really the very heavily related about the light, especially the indoor light, the disruption, and the indoor light is not really good enough to support our circadian rhythm, also the mood, productivity, something like this. So depends on the according to the latest development about the semiconductor lighting. Now I think easily everyone can get a full spectrum LED compared to the 10 years or even 20 years before. Is really the very difficult. But today, I think that we can really easy to enjoy the full spectrum LED, which you can see in the middle and in the three picture here. The left-hand side is the CRI-AT LED, and in the middle is the full spectrum LED. And the right-hand side is the nature light, which is measured by our products, the English Ultra, to measure the spectrum. So you can see actually the visible light, actually the full spectrum LED could be very similar to support the people especially not only to simulate the nature light, but also can utilize the solid state lighting technology on the dimming spectrum, mixable spectrum, and the multivariate dimming capabilities to really utilize all these functionalities to support the different agendas the circadian rhythm, for the emotions, or even different agendas. So also because of some researches for light and health, I think to really make us to understand the impact from the IPRGC, and also all the methodology, this and that. But I think the put together the solid state lighting and this the recently the science finding. I think that we're still at the very starting point to find out more and more possibility for light and health. And this is some example what we have worked together with the Fudan University in Shanghai. We started these researches in 2022, but unfortunately because of the COVID-19, we have not finished all these researches yet. So we try to identify individually different people's the historical sleeping cycle, very individually from the different age, different genders, and try to build up some like a DLMO to really try to find out some algorithm for the circadian phase resetting to really support the people to reset their circadian rhythm to follow the the health agendas. So I think this is a very interesting researches, and I think that in the future, I think that if we have a more and more the finding, I think that I can disclose more finding to the Good Life Group for you guys reference. And I think here I would like to also use the WELL standards. I think most of the people knows this standard, which I think is the probably the one of the most comprehensive describe how to utilize the natural light put together with artificial lighting, and in the different agendas, including the like exposure visual lighting design and the circadian lighting design, electric light glare control, the daylight design strategies, the daylight simulation, the visual balance, electrical light quality definition, and also utilize some occupant lighting control to support the people individually use the light to support their task or their human health. So I think it's a very good example to really support us to understand how to design and how to define the good light for the indoor health lighting design. So the well light concept really promote the exposure to light and aims to create a lighting environment that promote a visual, mental, and the biological health. And the well light concept really aims to provide a lighting environment that reduce the circadian phase disruption, that improve the sleep quality, and also positively impacts the mood and productivity. And this is the example how they use the L03, how to use the artificial light to support the circadian lighting design. So they defined in the daylight, in the daytime, especially before the 12 o'clock, the PM, before the noontime, you need to start to stimulate your eye level more than greater than 250 EDR lux. So I think they also translate to EML. It will be the greater than 275, and they provide also some verification method, which I think is the very comprehensive to have the ideas, have the standard, and also have the method for the verification. And here I would like to share some of my study with some the association. and also working together with to build up a more and more standard to support the different indoor lighting scenario. But I think that from overall, in general, we think the design logic for the healthy lighting, indoor lighting, must be when different people they engage in different activities in different spaces and times. This demands for the physiological and psychological diversified scenarios. So we need to support individual impact should be the support the make it to be comfortable, safety, visual acuity, and also include some artistic. And in the non-visual impact, no doubt we need to support the circadian rhythm and also support our emotion, the mood. So the logic and the priority of the indoor healthy lighting design. I think for the it's very complicated, especially in the space. You always have a different visual task. You always have different activities, this and that. So how to define and prioritize the design logic, I think it's quite important. So I think the priority one, everything needs to based on the national standards or global standards on the visual safety task and energy saving requirements need to be also in line with the WELL standard, the L01, L02, the light exposure and the task, visual task. And number two, I think that we need to take the circadian rhythm lighting design as the preset scene. And the next, we need to take the needs of the activities at a priority scenario. Means if we're not doing some specific task like a reading or gathering or entertainment party something, then the default lighting recipe, lighting design should just follow the circadian rhythm needs. But in case we need some activities, then we just take the priorities for the activity. But nevertheless, if we can put all this together, like also we can, like for the reading, if we want to read in the nighttime, just avoid to impact the eye level, but also support good enough for the horizontal eye level on the table, on the book, something like this. I think there's something the skill that we can use, and also on top of this, we can also use the emotional light as an optimized thing. And on the equipment, the facility, I think also we did some default, like for the light source, the RA, and also recently the CI also highlight the importance to put together with the IF. So here, if the CI could I could greater than 90 would be great, but at least need to be greater than 80, and the R9 should be greater than 50. Also, because of the also the SDCM, better to be in within the 5 steps, and the lamps, the UGR, better than under 16. But I think the recently the IWI also tolerate to be 19, which is still fine. And the flickering, I think, is very, very important, especially together now more and more dynamic lighting system, control and controller drivers is more complicated. So in the flickering in the space, I think the coming from the controllers, the drivers, and also the dynamic lighting sense, I think that really raise more and more impact for our, not only the visual comfort, but also for our brand web, which I think that we need to pay some more attention on this. And this is something that also that's most likely that very dedicated to work together with the IWBI to renew the standards. So the core difference, I think, between the healthy indoor lighting and the traditional lighting design. I think the traditional lighting design will more focus on the visual task and the safety requirements with the horizontal illuminance as the main appeal, along with some visual comfort requirements. And the healthy indoor lighting design, most likely will highlight the vertical illumination, especially on the eye level, which is the very, very important for the circadian stimulation and also for the visual comfort, visual sensitivity, frequent glare, something like this. So I think that's the very, very different compared to the traditional lighting design and now to get we talking about the healthy lighting design. This is, I think, the key differences. And today, I think is still many of the standards is really the far behind on the healthy indoor lighting design. So I think I really, especially I always talk to Yan and many peoples. If we can like learn from the EV, how they define the autopilot, level 1, level 2, level 3. So maybe we can consider like today the standards to be like a level 0, which is most likely the support the visual task, safety, and accuracy. But I think level 1, something like the well standard, really the just protect ourselves to like not been further been damaged, disrupted by the dark daylight and maybe in the nighttime too bright. So prevent to protect us from the very, very bad lighting environment as for the level 1. But I think that for the level 2 should have something like it could be the doing the phase resetting, especially the most of people already have the like a sleeping cycle disruption issues. So we do need some lighting strategy to really enhance and doing support the fast resetting to make us to back to the right track. And level 3 should be some medical level. Okay, so but I think the also for the like a level 1, even the IWB, I think there's some like also the thank the Yan to remind me the mid level, mid level for mostly like it now is talking the more for the like elders, 30-year-old persons. But I think the for the elderly, I think that exactly we need to have a 2-3 times more light to really generate the not only the circadian rhythm, but also I think that for some visual acuity issues. So I think this is something that pretty missing, and I think that we probably can utilize our influence to support the industry to improve the standard, to install into the building standards. And the future, I think ideally, I think the lighting should be something like adaptive intelligent lighting system, which I think most likely could be would be the sensor driven and the interactive lighting system to ensure the lighting environment to really meet the design goals in real time and embedded with many different standards and design target to make it happen. So this is basically my ideas to have a sensor installed in the space to collect the lighting effect from the space and to compare against the various standards and design targets. And the system will close the gap automatically to ensure the lighting environment complies with the targets. I think it would be the future, I would say, if we all understand the lighting, especially now AI and the IoT coming to be more and more popular. And I do believe the lighting system can really position ourselves to really integrate with more and more the latest technology. Means I think it's really good opportunity that we can make the light as a service to be a true thing. So we need to support the SaaS-based, at least, the software as a service. In our lighting prayers would be a light as a service. And on top of this, maybe the big companies like Signify, like Zontobo, something like this, big guys, could support also some platform as a service to provide some design tools and even build up some ecosystem and interact together with the different lighting players and even many different ecosystems. And on top of this, there would be an infrastructure as a service. And I think that would be, we need to partnership and work together with some infrastructure guys to really embed it with them to provide good support to all of the building and especially the home householders on this. So this is our latest product, which is the first. I will always say the human-centric light meter. That Yan always taught me maybe better to be the healthy indoor healthy lighting. But I think the difference, why we have this, because I think that we need to have this to measure the lighting effect, the quality of life from the human-centric, not only the indoor, but also the outdoor, including all of the quality of life factors. This is what we want to do and also put together with our research and some interaction with some many the lighting players. I think that we would like to support people and support especially the big guys and the association to work together with the healthy lighting design concept and fill the gap to support everyone. Thank you.
Okay. Thank you very much, Lawrence, for a very interesting presentation, insightful. And I think your 3-level approach, hero plus 3-level approach, is a very interesting one. I think we definitely need to follow up on that. I see 3 questions. We have 2 minutes left. So let's do the quick questions and also especially quick answers. Joachim was the first one.
Yeah. Okay, so thanks for a very interesting presentation. So I have a question regarding the WELL standard, and it might be that others here know the answer, but as far as I can see, when you go into offices, you still have this 250 or sort of during a specific time of day, but I don't see that ties into the night for offices. And if that's the case, have anybody sort of taken this dialogue with Tony Esposito at the IB Well? Because potentially what that would mean is that if you are sitting at an office and you actually work into the night, you're still exposed all the night to 250 and you would still get 3 points from WELL.
Yeah. So thank you for your question. But I think if I understand correctly, you mean the night shift workers, or you mean the overtime?
No, not necessarily. I'm thinking if I look just at the offices, it basically describes sort of throughout the day. If I go to residential areas, there is a requirement for nighttime, but I don't see that in the offices. So if you work late, what happens then?
Okay, let's.
Then you're basically exposed to 250 millinopic EDI all evening.
We must secure that in the evening you are below the maximum level of 10 lux. Yeah.
Yeah.
Okay.
And you don't get that now, as far as I can see.
Yeah. That's a good point to take along in the WELL discussion. Thank you, Joachim. Quickly to Oliver, please.
Yeah, maybe I won't ask a question, but just say that this was a wonderful presentation and that I fully support your ideas. I think it's wonderful to see such a presentation, and I thought you might be interested in this article which I put into the chat, because it addresses very similar things, and I would love to stay in contact somehow.
Okay.
Good. Thank you.
Okay, thanks. And last but not least, Kevin.
Hi. Well, 2 points on the WELL point that was just made. you don't require to keep the 250 lux up all day and all night. There's a limited number of hours you need to provide that for. So that's covered already in well. In relation, and also adjacent to well, the question I had was that you were asking for a UGR of 16, but then expecting to get melanopic lux of 250 at the eye. I've been looking at that quite closely in relation to the paper I've been writing, and I believe these two things are incompatible. I just wonder what your thoughts were as how you might manage to achieve the UGR 16 plus the 250 lux in the eye, plus a reasonable overall lighting level in, within the expectations of most building types.
Kevin, thank you for your question, but I think the UGR issue, I think is quite, it's a very, very different agendas, but I think the most likely today, the UGR for well, they not only ask for the UGR check for the equipment yourself, but also for the design, the installation in the space. But I think also they define the contrast, the visual contrast in the space. So I think there may be later I can share also the more comprehensive the world standards, and also because of limited time we can discuss afterwards. I will show you the more details of the standard and also my thought behind it. Okay.
Right. Well, I mean, I've had this conversation at length with Tony Esposito at Well, and he's kind of come to the same conclusion as I have, is that in the Well standard, you can't meet the higher requirement for the diurnal lighting and the requirement for UGR, which they've now changed from 16 to 19 anyway. He says that, well, if this comes up on a project, go to him directly and then make an assessment on a project by project basis. But I think fundamentally we've got to be careful with this, because we are asking for a high level at the eye to make it work, but we're also expecting to have, well, UGR is a problematic measure anyway. We're still expecting to have low glare, and the two things have a compatibility problem. So I don't know. I think we just have to be careful when we're talking about this to say that maybe we can't actually do both things at the same time. And also we would need to look at glare and find some other way of measuring it, or doing something. I mean, the other problem with well and glare is that you can meet the well glare requirement by using fittings that are stated to be a certain UGR. And if you understand UGR properly, you know that fittings don't have a particular glare rating. It's the glare rating of the observer at position, and it is very poorly calculated on most projects these days. So it's a problem.
Okay.